Hi everyone. I noticed that from Wednesday, barely anyone was able to get through the homework, so I felt like I should review this with you, at least in my own video. Hopefully it helps even a little bit while I'm gone. So here we are. Okay, today's FLT is given a quadratic of the form ax squared plus bx plus c. We will be able to rewrite it as a product of two factors by using the x method to organize information. Okay, for today's homework, it's going to be the same as Wednesday's homework. There is a Delta Math assignment 1.6. Okay, and I added on a nice little section in case you did finish it on Wednesday. There's just a couple more problems that I want you to try. All right, so as a review, factoring is basically the reverse of distribution or undistributing, okay? So let's get into it. When we factor out, you're basically undoing distribution. So specifically with factoring out the GCF, you want to find the largest value that goes into all terms of your polynomial. So looking at number 1, imagine we want to factor this guy completely. So between 9x and 15, I'm thinking of the number that can go into both evenly. Okay, what's the biggest number that goes into both evenly? Well, that's 3. Okay. And that's the only thing I can pull out, right? If I were to rewrite this, okay, 3 times 3 times x, and that's 3 times 5, right? So if I take out this 3 and that 3, that's the 3 that comes in front. So what is left over inside this binomial? 3x and 5. Okay, and that's it. Okay, number 2. We have 5x squared minus 6x. All right, this one's a little different. Okay, between 5 and 6, they don't share a common term. However, I can rewrite this, or I can rewrite each term as 5 times x minus 6 times x. If you compare the x part to each other, I see that I can pull out 1x from both. That x will become my GCF. That's the only thing they have in common here. All right. So what's left over in our binomial? We get 5x minus 6. Okay. Again, what just happened? Between 5x squared and 6x. The most amount of x's that I could pull out from each of those is 1. So that got factored out. What was left over in this binomial is 5x minus 6. Okay? So let's look at number 3. Okay, between 20 and 15, I know I can factor out a 5. Okay, so if I rewrite this, this is the same thing as 5 times 4 times x times x times x times x plus 5 times 3 times x times x times x. Okay, so we pulled out a 5. That's going on the outside. Now, what's the largest amount of x's that I can pull out from each term? The largest amount that we can pull out from each are 3. And notice 3 is the smallest exponent between the two of them. So, along with the 5, we can also pull out x to the power of 3. Okay. So what's left over in each term? 5 times 4 gives me 20. x cubed times x gives us x to the fourth. 5 times 3 is 15. And there's no more x's we have to multiply to it, so that's it. Okay? So for number 4, how do you rewrite this if you factor out the GCF? Okay, your final answer should be 4a squared times 2a minus 3. So before we dive into factoring or reviewing factoring, I want us to think about what it is when we multiply, right? Now, when we were working with multiplying problems, we would see something like, let's take a binomial x plus 6 and multiply it to x plus 3, right? So when we do this, we would either FOIL or we would use box method to find that we get a trinomial, and in this case this would equal to x squared plus 9x plus 18. Okay. Now, what we're doing with factoring, we're basically starting with this and going the other way. Okay. Now, how exactly are we going to do this? We're going to try using this method called the X method. All right. So, let's take a look at this one here. Okay. For number 1, we have x squared plus 6x plus 8. Okay. Now let me go back to this guy really quick. Okay. And I want you to see something. Something interesting is happening here. Okay. There's a relationship between these values and the values that end up here. And this. Okay. In our original factors, 6 and 3. 6 times 3 gives us 18. 6 plus 3 gives us 9, right? This pattern is what helps us figure out how we rewrite this guy as a set of factors, okay? But there is a way to organize this information visually. It's a little bit nicer, okay? So, we essentially want to rewrite this quadratic as 2 factors, where if we multiply them out, we get back this guy, right? Now, let me scoot over here again. Notice that the first term has to multiply to x squared. So in this case, it's always just going to be x times x, all right? X times x will give us x squared. Cool. Now we're trying to figure out these 2 values here, okay? So the way we're going to figure this out, we're going to use this guy, this x, to sort of visualize the information a little bit nicer, okay? So what we're trying to do here, we want 2 numbers that multiply, that multiply to 8 and add to 6. Okay. So in this little x, we're going to just use it to organize the information. So we're going to jot down an 8 here, and a 6 here. Okay, this is our little reminder to ourselves that we're thinking of two numbers that we're going to place here and here that multiply to 8 and add to 6. Okay, so two numbers. I'm thinking of 2 and 4. Okay, why did I go with 2 and 4? You always want to start with numbers that multiply to the constant, that multiply in this case to 8. Okay, that's either 1 and 8 or 2 and 4. I chose 2 and 4 because not only do they multiply to 8, but they also add up to 6. So let's try this out. Okay, plus 2 and plus 4 because it's going to multiply to positive 8 and add up to positive 6. Okay, so this is sort of our guesswork, okay? But we do want to check it, all right? So when we check our work, this is where foiling or distributing can be a little bit quicker than the box method, okay? All you're going to do is FOIL it out to see if you get back your original statement. So when we FOIL, we get x times x is, sorry, I'm going to use a different color to check my work. So x times x is x squared. X times 4 is 4x. 2 times x is 2x. 2 times 4 is 8. Okay, 4x plus 2x will then become 6x. And notice that we ended up with our original problem, so that means we factored correctly. Okay, let's try another one. All right, so again, we want to find a way to rewrite this as two factors that multiply to each other. We know that the first terms multiply to x squared, so that's just x times x. So when we set this up, okay, again, this part is just a nice way to visualize the information. It just kind of pulls out the information we need. Again, we want to figure out two numbers that multiply to negative 70 this time, but add up to positive 3. Okay. Two numbers. All right. Multiplying to negative 70, but adding up to positive 3. In my head, I know I'm going to work with 7 and 10. Why did I choose 7 and 10? Because I know 7 times 10 will give me a 70. All right. And I can manipulate it so that if one of them is negative, then I can somehow end up with 3, right? So if it has to be positive 3, okay, I'm gonna attach that negative sign to negative 7. So let's check it really quick. Negative 7 times 10 is negative 70. 10 plus negative 7 gives us positive 3. Okay, I think I'm on the right track here. Yes. Okay, so double checking your work. I'm going to FOIL it out. FOIL it out. So we end up with x squared. Oops. Plus 10x minus 7x minus 70. Okay, the ones that you really need to check here you mostly want to see if it adds up to this middle term. Okay. So 10 minus 7 will indeed give me 3. That means this is correctly factored. All right. Okay. I want you guys to try this one out. Pause and try it. Include your answer on the prompt. And what do you get? Okay, I'm going to continue with this solution here. This one should be x and x. This time it's a minus and a minus. 9 and 2. Okay. So double checking the work here. Again, thinking about it. We need two numbers that multiply to 18 and add up to negative 11. So in my head, I have 9 and 2 here. But in order for them to add up to negative 11, they would both be negative, right? Thinking about it. Negative times a negative gives me a positive. Negative plus negative gives me that negative, all right? And to triple check our work, foiling it out again, okay, we get x squared minus 2x minus 9x plus 18, okay? Negative 2 minus 9 equals negative 11x. That means this is factored correctly, okay? All right, congratulations on making it this far. The last type of trinomial we're going to factor today is one that's a little bit different. This time there will be some number in front of x squared where the number is not 1, right? We're mostly going to look at ones that are, whole numbers, either positive or negative. I think mostly positive in this case. Yeah, positive. So, here we are. The instructions are factor completely. Okay, with this method, we actually have to use guess and check. Okay, I know it can be challenging, especially if your mental math skills aren't the strongest, but yeah, I think we can definitely do it. So here we are. Okay, now when we guess and check this, okay, we unfortunately have to switch it up, right? The first terms now have to multiply, in this case, to 5x squared. All right, so it's going to give me 5x times x. 5x times x will give me 5x squared. Okay. But what goes next are factors that have to multiply to 20. Okay? Multiplying to 20, and somehow along the way, when we manipulate it and check our work, they're going to also add up to 29x, okay? With taking this 5x into consideration, all right? So bear with me. Factors of 20. We can try 1 and 20, 2 and 10, or 4 and 5. Okay. So let's see. What would make sense here? Let me just try 4 and 5. Okay. So let me put down a 4. Let me put down a 5. Okay. Now I'm going to show you a quick way to check your work. Okay. And this works for the other ones too. In order to quickly check your work, since we already know 5x times x is 5x squared and 4 times 5 would be 20, we only need to figure out, okay, does this combination add up to 29x? So when you check your work, take 5x times 5, which is 25x, and add it to 4 times x, which is 4x. Okay, if this gives you this, then you know you factored correctly. So 25x plus 4x, we end up with 29x. So that means this was factored correctly. Wow, first try. So that's essentially what guess and check method looks like. Okay, so let's try another one. Let's do 3x squared plus 19x plus 20. All right. So for our factors, we know that this time the first terms have to multiply to 3x squared. So that's just going to be 3x and x. Okay. But again, we still need to consider, okay, for these two here, they have to multiply to 20. So we're going to consider 1 and 20, 2 and 10, and 4 and 5 again. Okay. So thinking of a combination, let's try 4 and 5 again. I have a good feeling with 4 and 5. I feel like when I check my work, I can somehow get 19x from that. Okay. I know I can, well, really quick, I know I can eliminate 1 and 20, okay, because 20 is too large for it to become a 19. And same with this 10, right? I can eliminate that 2 and 10 only because I feel like it just is not going to work out there. Okay, so when we write this out, let's try 5 here and 4 here. Okay, checking our work. 3x times 5 is 15x, plus 4 times x is 4x. So 15x plus 4x is 19x. Wow. First try again. Yay. So here we are. That would be our final answer. Okay. Now, when you're working on these problems, it's probably going to take you a bit more time to figure it out, and that's okay. All right, take your time as you need. And if you have questions, ask your neighbor. And if both you and your neighbor have questions, you can email me. All right.